Now we will begin working on Chapter 5, Exponents, Polynomials, and Polynomial Functions. Remember to print out the corresponding lesson pages so that you can follow along and work through the problems as you view the video. In Section 5.1, Integer Exponents and Scientific Notation, we're going to use the product rule for exponents, define zero and negative exponents, use the quotient rule for exponents, and use the power rule for exponents. The product rule for exponents is as follows. If m and n are natural numbers and a is any real number, then a to the m times a to the n is equal to a to the m plus n. In words, when multiplying powers of like bases, keep the same base and add the exponents. Here's an example. If you have 2 raised to the third power times 2 raised to the fourth power, you can write this as 2 raised to the 3 plus 4 power, which is the same thing as 2 to the 7th power. You can think of it this way to confirm. A way to write 2 to the third is 2 times 2 times 2, and a way to write 2 to the fourth is 2 times 2 times 2 times 2. So if you count all those together, you'll see that you have 3 2's and then followed by 4 2's all multiplied together, so that is equal to 2 to the 7th power. So our shortcut here is if you have your multiplying and the bases are the same, then you are going to add the exponents together. On this slide, we're going to do a few examples here. Apply the product rule for exponents. In part A, we have 5 to the third power times 5 to the second power. Now that's the same thing as using the product rule. Remember, the product rule is a to the m times a to the n equals a to the m plus n. If the bases are the same and you're multiplying, then you can add the exponents together. So this would be the base of 5 raised to the power of 3 times 5 to the power of 2. We can add those exponents together, and we can write our final answer as 5 to the 5th power. We can do this with bases that are variables as well. In part B, we have x to the third power times x to the 6th power. Now the second x here does not have a power, so we automatically know that the power needs to be 1. It's just not written there. So the way we simplify this is by adding the exponents. Because all the bases are the same, we can write this as x to the 3 plus 1 plus 6 power, and when we simplify that, we get x to the 10th power. Let's look at part C here. We want to multiply these quantities, but notice that this 2 does not have a power. We can say that that is equal to 1, and so on. So we have coefficients that we're going to multiply together first. So we can write this as 2 times negative 3 times 4, those are the coefficients, times the variables, p to the 4th times p to the 3rd. So we can multiply the p's together. Since the coefficients are multiplied together, we can multiply 2 times negative 3 times 4 to get negative 24. And because the bases are the same with the p's, we can write this as p to the 4 plus, don't forget that power of 1 here, 4 plus 1 plus 3. So this can be simplified to negative 24 p to the 4 plus 1 plus 3 is the 8th power. So we can simplify part C as negative 24 p to the 8th power. In part D, we can't simplify this any further because in order to use the product rule, the bases must be the same, but the base A is different than the base B. So the only thing that we can do to this is write this as 7a to the 3rd times b to the 2nd power. the bases are not the same, you cannot apply the product rule for exponents. Now a zero exponent, if a is any non-zero real number, then a to the 0 power is equal to 1. Now you can try this on your calculator with any base a, as long as it's not 0. For example, if you have 5 raised to the 0 power. Now the calculator buttons, you should be familiar with your exponent buttons on your calculator. So depending on what version you have, what type of calculator you have, you might want to look for this arrow up button to the 0 and press enter, or some calculators will have this y to the x button and then 0. So that locate your calculator, practice with your calculator so that you know what buttons to push as we get to some of the more complicated problems. So when you do that 5 to the 0 on your calculator using any of those, you should see that it does equal 1. Now a negative exponent, for any natural number n and any non-zero real number a to the negative n power can be written as 1 over a to the n. And often when we're going to be doing the homework sections, that we want to be able to write our answers using only positive exponents. So if you end up with a negative exponent, know that you can write it as a positive exponent by changing the location. If it's in the numerator, we can think of this as a to the negative n over 1. We can move that negative exponent to the denominator and it becomes a positive exponent. For example, if we can write a base, say 3 to the negative 2 power, that's the same thing as 1 over 3 to the second power. And we can even write this as 1 over 9, because 3 to the second power is 3 times 3, which is 9. Try that as well as on your calculator and see if you get the 1/9. You may also need to use the fraction button on your calculator and be familiar with how to use that. And then, so you on your calculator you would type in the 3 in either the arrow up button or the y to the x button with a -2, and you may get a repeating decimal, so you want to convert that to a fraction. And again, depending on what calculator version you have, you may want to look for this FD button, fraction to decimal or decimal to fraction button, so that you can convert any decimal answers to fractions. Here are some examples using 0 as an exponent. In part A, we want to evaluate 5 to the 0 power. While using that property of a to the 0 is equal to 1, then we can say if the base is 5, 5 to the 0 is also equal to 1. Now -7 to the 0 power is also equal to 1. Now with part C, be careful here, because we have -7 to the 0 power, but that negative in front of the 7 is really a -1 times a 7 to the 0 power. And remember the order of operations, you're going to do exponents before you do multiplication. The P for powers, E for exponents, and then the multiplication and division from left to right, and then addition and subtraction from left to right. So we want to do exponents before we do multiplication, following the order of operations. So -7 to the 0 power is 7 to the 0 power, and then multiply that result by -1. So the answer for that one is -1. Now in part D, it's the opposite of -7 to the 0 power. So that, if we do the parentheses first, -7 to the 0 power is 1, and then you make it negative. In part E, we have 6 to the 0 power, and 6 to the 0 power is 1, plus 12 to the 0 power, which is also 1. Remember, we do exponents before we do addition. So we can get our final result as 1 plus 1, which is equal to 2. And then finally, this last one is done for us. 8y to the 0. This quantity is raised to the 0 power, so this is simplified to 1. All right, in this slide, we're going to be writing our answers using only positive exponents. We have 5 to the negative 3 power using that property of exponents where a to the negative n power is equal to 1 over a to the n power. So any negative exponent can be written as a positive exponent. So we can write our answer for part A is 1 over 5 to the third power. Now you can leave it as 1 over 5 to the third, or you can simplify this as 1 over 5 to the third, which is 125. For part B, 7 to the negative 1 power is the same thing as 1 over 7 to the positive 1 power, and then that can be simplified to 1 over 7. In part C, we have the quantity of 2p to the negative 2 power, and that can be written as 1 over 2p to the second power. And this, using the power rule for exponents, we can write this as 1 over, you want to make sure to share that power of 2 for each of those, 2 squared times p squared. And then to simplify this one step further, we can write this as 1 over 4p squared. And again, going back to the fact that the entire quantity 2p was raised to the negative 2 exponent, we moved it to the denominator. In part D, the only thing raised to the negative exponent is the z. The 6 is already raised to a positive 1 power, so we don't move the 6, we only move the z. And that becomes 6, we can keep that in the numerator, and z to the third goes in the denominator. And we can leave our answer in that form. In part E, notice that we have this negative out in front. That's the same thing as negative 1 times a to the negative 4 power. So the negative 1 is already raised to the power of 1. We're going to keep the negative 1 in the numerator, and then a to the negative 4 becomes an a to the positive 4 in the denominator. In part F, the entire quantity is raised to the negative 4 power, so we can write this as 1 over negative a to the 4th power. Now the negative out in front is the same thing as negative 1 times, so we want to share that exponent with the both terms that are in the parentheses, and we can write this as 1 over negative 1 to the 4th power times a to the 4th power. Now negative 1 raised to the power of 4, it's an even power, so this can be written as 1 over a to the 4th, because negative 1 to the 4th is equal to 1. So there we have our answers that involve writing negative exponents as positive exponents. On this slide, we're looking at special rules for negative exponents. If a does not equal 0 and b does not equal 0, then you can write 1 over a to a negative exponent as a to the positive exponent of n. You can also write a to the negative n over b to the negative m. You can make those exponents positive by changing the location. The a to the negative n in the numerator is written as a to the positive n in the denominator. The b to the negative m in the denominator is written as b to the positive m in the numerator. The quotient rule for exponents says if a is any non-zero real number and m and n are integers, then a to the m divided by a to the n is found by subtracting a to the m minus n. In other words, when dividing powers of like bases, keep the same base and subtract the exponent of the denominator from the exponent of the numerator. here's an example. Say we have 3 to the 5th power over 3 to the 2nd power. We can expand this out and write it as 3 times 3 times 3 times 3 times 3 in the numerator and 3 times 3 in the denominator. Now that common factor in the numerator and the denominator can be simplified, so you end up with 3 3's in the numerator, or 3 to the 3rd power. So we could have gotten this result using the quotient rule for exponents. So 3 to the 5th divided by 3 to the 2nd. Since the bases are the same, you can simplify this by subtracting the exponents. 3 to the 5 minus 2. And that 5 minus 2 exponent is the same thing as 3 squared. So we're going to use that result in some of the next examples. In example 5, we're using the quotient rule for exponents. And if possible, write each result using only positive exponents. So remember that the quotient rule for exponents says that if you have a to the m divided by a to the n, you can simplify it as a single base a to the m minus n exponent. And we're going to use that rule for these examples. 5 to the 7th over 5 to the 3rd is the same thing as the base is the same, 5, and then with the exponents we're going to subtract 7 minus 3. When we simplify that, we get 5 to the 4th power. For part B, these negative exponents, we can do this a couple ways. If we apply the quotient rule, we can write this as w and subtract the exponents. Since the bases are the same and it's a division problem, you can subtract the exponents, and we get -3 minus a -7. When you simplify the exponents, that minus and negative becomes a positive, so this can be written as w to the 4th power. Another way to take care of this problem, or an alternate approach to this problem, is to rewrite this as positive exponents first and then use the quotient rule. So this w to the -3 in the numerator, we're going to bring it to the denominator as a w to the +3. This w to the -7, we're going to write it as a w to the +7. And then we can apply the quotient rule. Since the bases are the same, we can subtract the exponents, and we can write this as w to the 7 minus 3, which simplifies to w to the 4th. Now in part C, you may want to try to use the quotient rule, but the problem is that the bases are not the same. So this cannot be simplified. And we would write our answer just as a to the 3rd over b to the 4th. Okay, the power rule for exponents is used if a and b are real numbers and m and n are integers. Then for part A to the m raised to the nth power is equal to the a to the m times n. So let's just look at part A to begin with. A to the m raised to the n. When you have a power raised to a power, then you multiply the exponents. To raise a power to a power, multiply the exponents. For example, if you have 2 to the 3rd power to the 4th power, that's the same thing as 2 to the 3rd 4 times. And then from our previous rule, the product rule is if the bases are the same, then you add those exponents together. So you can write this as 2 raised to the 3 plus 3 plus 3 plus 3, or 2 raised to the 12th power. So the power rule for exponents allows us to get this answer without doing those extra steps. If you have the base 2 raised to the power of 3, and then that's raised to the power of 4, the power rule for exponents says that we can multiply those exponents together. 3 times 4 to get the power of 12. In part B, to raise a product to a power, a to the b, ab, which is the product, to the m power, we raise each factor to that power. It's like we're sharing that exponent of m with both terms that are in the product. In part C, if you have a quotient raised to a power, that power m is shared with both the numerator and the denominator, and written as a to the m over b to the m. Okay, in this example, we are going to use the power rule for exponents. The first one is started for us. Simplify using the power rules. 3c is the entire quantity to the third power. We are sharing that power of 3 with both terms that are in the parentheses. So we can write this as 3 to the third times c to the third. You can leave it like that. You may need to simplify 3 to the third as 27 and write your final answer as 27c to the third. For part B here, the second example, the quantity x squared y cubed to the fifth power, we are sharing that exponent with both terms. So we can write this as x squared to the fifth power times y to the third to the fifth power, and then use the power rule for exponents. The power rule for exponents says if we have a power raised to a power, we multiply those powers together. So 2 times 5 gives us 10. For the y, we have the power 3 raised to the power of 5. Power to a power, we multiply to get 15. And that's how we can write our final answer. In the third example, the quantity negative 2a cubed b squared, we are going to be raising negative 2 to the second power, a cubed to the second power, and b to the second power. And it's going to look like this. We have negative 2 to the second power, a to the third to the second power, and b to the second power. Now negative 2 to the second power is a positive 4. For the a term, we have a power to a power. Using the power rule, we multiply those exponents together to get a to the sixth power and b to the second power. In the fourth example on the right here, we have the quantity negative 3x to the third over y, all of it raised to the third power. We are going to use that power of 3 with all of the terms that are in the numerator and the denominator. So it's going to look like negative 3 to the third, x to the third in the numerator, and y to the third in the denominator. Then when we simplify this, negative 3 to the third power is negative 27. X to the third power, power to a power you multiply to get x to the ninth, and then y to the third in the denominator. Okay, the last example in the bottom left, we want to share that power of 2 with all terms that are in the parentheses in the numerator. And that is going to look like 2 to the second, a to the third to the second, b to the fourth to the second, all over negative 2. When we simplify this, 2 squared in the numerator is 4. Power to a power here, we get a to the sixth power because we multiply those exponents together, and b to the fourth to the second power, you multiply those to get 8, divided by negative 2, and then our last step, we can simplify 4 divided by negative 2 and get negative 2, a to the sixth, b to the eighth. All right, we have more special rules for negative exponents. If a does not equal 0 and b does not equal 0 and n is an integer, then a to the negative n can be written as the fraction 1 over a to the n power. Also, the fraction a over b raised to a negative exponent n can be written as the reciprocal of the fraction raised to a positive n power. In this example, we want to write each expression using positive exponents and then evaluate. So here we are using the property that if we have the fraction a over b raised to a negative exponent is the same thing as the reciprocal raised to the positive exponent. So this we can write as the reciprocal 3 over 2 raised to the positive 3 exponent. And now we can share that power with the numerator and the denominator, and that will give us 3 to the third in the numerator over 2 to the third in the denominator. When we simplify that, 3 to the third in the numerator is 27, and 2 to the third in the denominator is 8. We can leave our answer in this form. For part B, we have this fraction raised to the negative 2 exponent. We can write the reciprocal of the fraction and raise it to the positive 2 exponent. Now we share that exponent with the numerator and the denominator to get 7 to the second power over 3 to the second power. When we simplify that, we get 49 over 9. All right, in example 8, we want to simplify each expression so that no negative exponents appear in the final result. Assume that all variables represent non-zero numbers. Now we can do this in several ways. For part A, we can use the product rule. If all these bases are the same and you're multiplying, then you're going to add these exponents. So it's going to look like x, the single base x, raised to the negative 3 plus 2 plus negative 4 power. When we simplify the exponent here, negative 3 plus 2 plus negative 4 is the same thing as the negative 5 power. We want to make sure we write our final answer using positive exponents. So this x to the negative 5 power can be written as 1 over x to the positive power of 5, and we can leave our answer in that form. In part B, notice that we have some negative exponents. We can rearrange the terms in the fraction so that we have only positive exponents. Now this x to the negative 2 power, we're going to write that in the denominator as x to the positive 2 power. The z to the negative 3 power, we're going to write that as z to the positive 3 power in the numerator. Now the y already has a positive 1 in the numerator, so we're going to leave it in the numerator. And then our final answer can be written as y times z to the third over x squared. So work on the homework assignments for this section, 5.1, and then come back to view the rest of the videos for Chapter 5.